The second grade standard OA1 requires students to use addition and subtraction within 100 to solve 1- and 2-step word problems using drawings and equations with a symbol for the unknown number to represent the problems. Problems include contexts involving adding to, taking from, putting together, taking apart, part, whole, and comparing with unknowns in all positions. This means that students should be provided ample experiences with 1- and 2-step problems that may include addition and subtraction within the same problem. Probably the most important aspect of this standard is that second grade word problems should contain the unknown quantity in different positions, which will be further illustrated in the following slide. It is also important for symbols like stars, triangles, or blanks to be used to represent the unknown quantity. Finally, students should also be still representing word problems with drawings and objects along with equations. This standard builds on the first grade standard OA1, which features adding and subtracting within 20 with the same 5 situations cited in the second grade standard OA1. That is, adding to, taking from, putting together, taking apart, and comparing, as well as unknowns in all positions. So really, the only two differences between the first and second grade word problem standards are the size of the numbers and the number of steps required to solve the problems. Finally, second grade OA1 prepares students for the third grade word problem standard that will feature all 4 operations. Also notice that students are not required to use a letter like X or N to represent the unknown until third grade. The standard OA1 actually includes a very important footnote that reads, "See Glossary Table 1." This is Table 1, which clearly delineates the 12 different ways that word problems can be worded to change the meaning of the word problem, as well as the placement of the unknown. Typically, the easiest problems to solve are those in which the result is unknown, as shown in the left-hand column of the table. However, as a critical building block for early algebraic reasoning skills, students need to be exposed to all of these types of problems, not just results unknown. This table can easily be transformed into an effective formative assessment tool, which is great because it will allow you to keep track of these types of problems students are proficient with and the kind they struggle with, which is much more powerful than simply stating that a child is having difficulty with subtraction word problems, for example. If you are not familiar with this table, now would be a great time to pause the video to analyze and discuss the different word problem types with your colleagues. If your students struggle with figuring out what to do with the numbers in a word problem, you might be tempted to teach your students to hone in on key words. But the problem with key words is that they are just tricks that do not always work and distract students from the underlying meaning of word problems. Here's a much better teaching strategy. If students are confused about what to do with the numbers in a word problem, why not just remove the numbers? This may sound shocking at first, but when we do this, students are better able to visualize what is happening in the problem. Once they understand the meaning of the problem, begin to gradually insert simple numbers one at a time. Discuss the meaning of the problem, draw it out, and gradually work up to revealing the actual problem, and you will be amazed at how much more successful students are in solving challenging word problems. Let's watch what this can look like in a classroom. Numberless word problems begin by reading the problem to students without the numbers added and asking what they notice is happening. Draw a picture illustrating what the students say. In this case, a tape diagram was the best model to show differences in lengths. Students then picked an easy number to work with and solved it. This allowed students to be successful with the context of the problem using numbers they could easily do in their head. Next, one of the numbers from the actual problem is revealed, and students use the same model and process as before to solve it. This allows them to apply number sense because students have to make their second number fit in with the context of the problem. Finally, all numbers from the problem are revealed and students can solve it. This teaches students to apply the same method when solving word problems on an assessment. They can look at what it is asking, try it with a simple number, and then solve the actual problem. Want more numberless word problems for all 12 types of word problems? Check out this link. Brian Bushart has created tons of free numberless word problem examples. Incorporating literature in math class is a great way to build background knowledge into story problems. The Georgia Framework's task, Counting Mice, does just that. This task uses 6 of the standards of mathematical practice, but the main focus is on 3 of the standards. Number 1, because students must make sense of a multi-step word problem and persevere in solving it. Standard 3, students are asked to share and evaluate the strategies of classmates. And Standard 5, because students must decide which tool will best aid them in representing and solving the problem. Begin by reading Mouse Count by Ellen Stoll Walsh. Propose a story problem based on the book. Discuss solution strategies together as a class. Next, read a modified story problem that requires 2 steps. Allow students the chance to choose their tool, base 10 blocks, number lines, 100 charts, etc., to solve the problem. Let's watch how students use different strategies to solve this problem. Notice the variety of strategies used.
So I did base 10 blocks, and so it says 25 plus 18. And so then it says he went and took an apple 14 miles ago. So you would take 14 now.
After students solve this problem, you can create a class picture or bar graph to chart different strategies used. Students then work independently to do 3 story problems based on the book.
So, first start with 29 and I added 18. So 10, 11, 12, 13, 14, 15, 16, 17, 18. And then when the snake came in from playing, 14 were only in the jar. So I minus until I get to 14. So 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29. And so 29 mice got out the jar.
The teacher asks formative assessment questions while students work. See the framework task for these questions.
How'd you do it?
I started at 25, then I plus 18. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Then I minus 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and I got 29 as my answer.
Inside Mathematics has a task called Incredible Equations that gives students a chance to use a story problem to solve equations with unknowns in different positions. This reinforces several important big ideas for students. Number 1, the equal sign means is the same as. It does not mean the answer to an equation. And students learned this in first grade with the standard OA7. Number 2, this task demonstrates how equations with a symbol, in this case a blank, for an unknown can look. Finally, let's take a look at 2 amazing resources for supporting student proficiency with OA1. First, if you want to create any of the 12 types of word problems we discussed earlier in the video, take a look at Greg Tang's word problem generator. Once on the site, pick the type of problem. Add to, take from, part whole, compare more, compare fewer, or random. For this example, we'll choose take from. Next, select the position of the unknown. Let's go with change unknown. You can even control the size of numbers. So for our beginning students, keep them small. Next, click the Generate button. And voila, you now have a customized word problem. For more proficient students, ramp the numbers up. Finally, as students are thinking about the solution to the problem, they can opt to see a hint, which represents the word problem in a bar diagram format, which helps students to better visualize the meaning of the problem. If you want students to have more practice, there's an option to create a list that can be projected or printed. The last resource is one of the best tools for developing understanding of the meaning of word problems, and it is called Thinking Blocks. This site allows the user to choose from a variety of addition and subtraction word problem situations. The motto of Thinking Blocks is simple. Word problems are easy to solve when you build a model first. So here's how it works. A word problem is presented, and in this case, we have a take from start unknown example. First, students must complete the bar model by dragging the bars and verbal labels to the appropriate areas. Then they drag the appropriate quantities in the symbol for the unknown. Then they solve the problem. At each step, students are given evaluative feedback. This is also a great tool for supporting and modeling close reading, as we must teach students the importance of breaking word problems down into more manageable parts and reading the problem several times in order to fully comprehend the meaning. All the while, students are using several standards of mathematical practice, such as making sense of problems, reasoning abstractly and quantitatively, modeling with math, and attending to precision.